here because I've got far too many notes and I will lose track of what the hell I'm talking about. But yeah, hi, my name is Danielle Summers, Engineer and Practice Manager and Lead Software Engineer at TFGM. Invariably, you're already aware of us, maybe even use their services to get here tonight. And you might also know about Andy Burnham's B Network, the new integrated, publicly owned public transport system that we've begun to deliver over the last month or so. So rather than giving you a bit of a death by PowerPoint talk, I'm going to lean heavily on what we've been doing over the last 12 months and kind of come back full circle into actually what I'm here to talk about today right towards the end. So it's going to be a little bit of a story. First up, I want to tell you that we had such a huge push right at the start to try and understand what it is we needed, and it became 4 key items for our digital infrastructure. We needed a brand new mobile application to replace the old Get Me There app, which incorporates new ticket purchasing, journey information, and as a side note, there's a lot of fun stuff that's coming with that app over the next 6 to 12 months. Next up is integrating the entire bus fleet across Greater Manchester with the existing Tap and Go solution that's been used on Metrolink. We needed to do a full revamp of our existing digital presence, including all of the data that we expose, not just to public, but also to private consumers as well. It's not just a website reskin. And finally, we needed to enhance our customer engagement platform to incorporate all of the new challenges and concerns that people would face that are unique to the bus network. Sorry, I'm going to scroll this out a little bit because I know I've got lots.
Do we not need any others?
No, we're good.
Cool.
So yeah, in order to achieve these goals, we had to scale my practice from just a handful, 5 engineers in 2020, to nearly 50 as rapidly as possible. And of course, the challenges didn't just end with staff. We needed to brainstorm the best possible technologies, frameworks, potential solutions to the list of challenges presented to us by the business. We knew from the start that there wasn't going to be a single or even a group of existing off-the-shelf products that we could purchase that would answer our needs. So we started to gear up very quickly to build everything ourselves. It's easy to think cutting edge is the same as future technology, with lots of fun things like AI and blockchain, NFTs, all being crammed into solutions that at a consumer level don't really need them. So as we began developing the digital arm of the B Network, I pushed to ensure that no idea was frowned upon. I tried to run a democracy where every idea and innovation, anything crazy, has got a chance to thrive. The problem we had right at the beginning was we were going to be hamstrung by a fixed budget and a fixed deadline, the 2 hated things for any agile advocate. So over the course of a few days, we scribbled out a full wall of all of the ideas and technologies. But we had to turn this wall of crazy stuff into something that was actually meaningful and that we could actually achieve. So I invented a term of a reality hammer. It was 3 questions that we had to answer. Is there a simple alternative that's possibly equivalent or better? Can we stand it up quickly? And do we actually understand it in-house? Is it something we know how to work with today? So over the course of a few days, we managed to work through all of this list and nail this down into something that was manageable. For example, a couple of easy ones we could answer. Generating NFTs on the new mobile app as the bus ticket. The thing is, QR codes already exist, they do the job, and we're not bothered about transferability. So we could bin that idea as something for another day. Of course, I pressed that button. Apologies.
Good.
Yeah, sorry. I have another note at the bottom. Another one is to expose timetable data to the public for free public consumption for IoT homebrew projects. The thing is, the APIs are already going to exist, the data is already going to be there, making it public is barely going to cost us anything. So sure, let's just do it. So once we built out this foundation and we understood what we were going to be delivering, we began to develop in earnest. Open source packages and solutions were a very quick early win where we only had to develop the bespoke parts that we needed, standing on the shoulders of the tech giants that have come before us. saving us from rewriting the wheel every single time we needed something. And then we could bring all of these disparate, different parts of this platform all together into some single, complete product, leveraging serverless technologies as much as possible to give us the scaling that we anticipated we'd need. Sure, the occasional corner was cut, like skinning some service pages wasn't necessary because the customer wasn't going to see them, or maybe there was something that was cut out of the MVP. But we delivered in 12 months what it took London several years to achieve. And when we finally got it all together in pre-prod and working, we were ecstatic. Of course, this amount of development in such a short period of time meant we had a big bang deployment to production. Many of my engineers stayed up overnight to ensure the whole deployment went as smoothly as possible, which of course it didn't. It was at 1:12 a.m., Monday the 25th of September, and I've got the logs. Less than 90 minutes after everything had been brought online, that the first service keeled over and needed to be coaxed back to life. Because of the size of a lot of the services we were deploying, we found that cold start times were horrific. In some cases, our alerting and monitoring systems were just screaming constantly whilst we waited for services to come up. Combined with a really weird circular dependency that we'd inadvertently created, day one was a bit of a nightmare for all of us. And then we hit peak usage. We hadn't anticipated such a rapid uptake of our new infrastructure, which resulted in several services struggling to scale, some services falling over when they did try to scale to that degree, and just a lot of crazy. You probably saw in the news, it wasn't the smoothest first few days. We ran daily hotfixes. We bashed out a lot of the issues very, very quickly. And it became quite stable, quite quick. By day 14, we realized we had other issues there. Our cloud compute costs had grown by an order of magnitude, and one specific service which refused to scale properly resulted in regular outages of one of the web pages on tfgm.com. Support requests had tripled past expected baseline, partly due to long load times with the website and the app, and perhaps an underestimation of how quickly this would be taken up and how many people would be using our new infrastructure. Everything was absolutely hammered, way more than we'd anticipated. We ran daily and weekly postmortems on everything that needed any attention, and the reasons all began to sound kind of similar. We were scaling hard to hide bottlenecks. We hadn't realized we'd got so bad during pre-production testing because we weren't testing for it. Everything running asynchronously, we weren't hammering hard enough to see these bottlenecks in testing. Now we had the workload hitting it constantly, we could see it very easily. Most of the services took less than a second to respond. They were perfectly fine. One in particular would take randomly over 30 seconds to respond, a staggering amount of time to fetch a small block of data. And the core reasons, some bad decisions early on, some corners cut, and a lot of unoptimized services. Dependency bloat was also something we saw quite early on, but we brushed it under the carpet as a problem for later. Now it really was a problem. Slowing down cold start times, hogging memory, and in several cases, the open source solutions we had just simply weren't optimized to deal with how much workload we were going through them. There's no single solution when optimizing dozens upon dozens of services, AWS Lambdas, web pages. We had to list all of the offenders from worst case down and start. Like with the reality earlier, we had to be strategic in how we tackled each performance issue without wasting time debating the nuances and specific details. So we built a 4-step challenge for each of these offenders. Services in high traffic environments needed a lot more urgent attention over those that had only been hit a few dozen times since launch. Then we needed to prioritize by how easy we assumed it would be to diagnose the problem, or to fix it, just to try and diagnose what that problem is. And then skipping the whole fix part again, how easy it is to prove that we've got the fix in place, how easy it is to test it. And finally, how easily can we deploy that new piece of kit, that new updated service into production without causing downtime? As mentioned before, we dealt with the stability issues and that stupid circular dependency issue quite early on. These were the really challenging ones, to make our services and features way more performant. So I mentioned it before, cold start times were our first priority, as they were considered to cause most of our slow responses, especially during scaling. In total, there were over 20 services that had a cold start time over 2 seconds, almost an eternity compared to our targets. The worst ones were simply poor design. We'd coded far too much into the initialization, too big of variables that were priming. We just also not accounted for the compute and memory cost, memory allocation, when we were designing and specifying how to host these. So there was a lot of very easy things that we could tackle. Starting off, just adjusting compute and memory allocation gave us a huge win. And of course, we're going to continue to work on these over the next few months, basically hitting the fundamentals with each one, avoid enormous functions, reducing variables, and adjusting memory and compute allocation. The service shown in red here was hilariously bad. Someone had, actually it's turned up blue on the screen. Somebody had pulled in a dependency on an open source project and manually compiled it down to run with inside the AWS Lambda. It was bad. Looking at our live response times for bottlenecks and performance improvements, again, the first round of cold start time fixes, just adjusting memory and compute for a lot of these services gave us a massive improvement. Then focusing specifically on performance. Some were easy, like just indexing a table. Others needed more intricate approach, better utilization of resources, branching optimization, flattening loops. There's a lot of different, very technical things we can do, line by line, to try and improve this and eke out an extra couple of milliseconds here and there. The weird spike on day 21 was an attempt to roll back the memory and compute, reducing it down after we thought we'd fixed the bottleneck, which we hadn't, and we kind of dropped the ball on that one. We thought it was an easy win. Turns out we ended up spending a lot more time on it because it wasn't. And of course, the one that I think a lot of you have been itching to see, our cloud compute costs. I mentioned a few slides back, we had a massive uptick in costs almost immediately after launch, and this will give you a bit of a picture of it. Fun fact, this slide initially was the last 52 weeks, it was the end of October, and it was basically a flat line with a spike at the end. Hopefully this gives you a little bit more clarity on what it is. Of course, I've removed the real numbers, it would just be crude of me to add those in. But every improvement we've made, no matter how minor, has brought these costs down. A very tiny reduction in execution time just means a small cost reduction, but at the scales that we're pumping out and the amount of times these services have been hit, everything adds up rapidly. As a public sector business that's built and run entirely on the public's money, bringing down our weekly and annual costs makes a massive impact to everybody. Saving money can enable more and better projects that we can execute, and potentially even, maybe in the future, reduce public transport ticket costs across the network. Making these numbers as low as possible without pouring all of that money into the staffing costs to bring this execution cost down is the balance that I'm trying to run every day. So with cloud and serverless solutions, it's really easy to fall into the trap of scaling really hard to meet demand. After all, that's kind of what they're there to do. But even Amazon have adjusted their models to move away from serverless to reduce costs where necessary. And while our usage is in no way comparable, we must look at the current technology trends and the current tech market leaders to show us where we can make similar savings without impacting performance for our user experience. And user experience is kind of key. To the end user, the difference between 600 and 700 millisecond load times on a page is nothing. They're not even going to notice it. When that difference is on a page that's used maybe 10 or 20 times a month, spending time optimizing that down is not going to see a monetary benefit for years. Hitting the high-performing, high ingress points, the high load points really helps to reduce those type of costs. And this leans heavily into chasing perfection, as there's no perfect piece of software, no matter how small or how inconsequential. Chasing perfection in engineering is an endless task, so leaning on SMEs to know when to stop is key to know when to cut your losses. And finally, an area that's very close to my heart is empowering engineers, both at a technical level and at a personal level. And that lets significantly improve your turnaround on fixes and improvements to your operation. This can be as simple as providing AI tooling, Copilot, that type of thing, or just celebrating their successes. If you can reduce the time needed for an individual to optimize a function or a service, you're doubling your gains, and it can be very, very cheap. So how is all of this relevant for tomorrow's tech today? Well, it's been said already, we're on the edge of a technical revolution on par, in my opinion, with the advent of the desktop computer or the smartphone. ChatGPT, AI development tools, deepfakes, NFTs, all of these technologies absolutely have a place, a valid place in our future. And as scary as that might be for some, using the right technology in the right place can drastically enhance both the products that we're able to deliver and at the same time reduce the costs associated with them. All of these exciting new technologies are already here and already being used. So I believe our focus over the next 12 to 24 months should be around optimizing our products and optimizing how we develop these products to leverage these new technologies in the right way for our customers. Throwing money at problems like my scaling issues here doesn't make the problems go away. It simply hides it. By shifting focus on optimization and overall improvement, we can lay the foundations for the best possible platforms in which today's technologies can evolve to meet tomorrow's needs. Thank you very much. And thank you so much.